Alright, let's take a look at an example of using the t-distribution to construct a confidence interval for the mean. Okay, so let's take a look at this commute time example. Okay, so the instructions are that we're given the sample mean and sample standard deviation. Okay, this is important. When the sample standard deviation is given, we're assuming that the population standard deviation is not known. Okay, so that's going to indicate to me that I'm going to be using the t distribution rather than the z distribution to find the critical value. Okay, so assume the population is normally distributed and use the t distribution to find the margin of error and construct a 95% confidence interval for the population mean. If convenient, use technology. Okay, so we'll go ahead and do this using the t-table, and we'll go ahead and do this using the calculator's built-in t-interval function. Okay, so the instructions say to assume the population is normally distributed. This doesn't mean we're using the z-distribution to find the critical value. It just means that the assumption of normality has been met for us to use the t-distribution. Okay, so in this particular problem, we're given a sample of 8 people. The sample mean was 35.5 and the sample standard deviation was 7.2. Okay, so let's put that down. Okay, so we're given in this problem that n was equal to 8 people. The mean commute time, x bar, sorry about that, was 35.5. and the sample standard deviation was equal to 7.2. Okay, so we want to construct a 95% confidence interval for the mean, okay, the population average commute time. Okay, so the confidence interval formula is x bar plus or minus t sub c times s over the square root of n, where this portion here is the margin of error. Okay, so what we're given in the problem is that we're given x bar, and we're given the sample standard deviation, and we're given the sample size. So all we need to do is to find this t sub c. Okay, so just like the last section, we want to go ahead and sketch a bell curve, okay, because the t distribution is bell-shaped with the mean equal to 0. And because we want a 95% confidence interval, we're going to partition the curve so that there's 0.95 amount of area between positive critical value and the negative critical value. Now we only need one to input into the formula, so we're going to find this positive one. Okay, so let's go ahead and look at the table. Now keep in mind, if I have 0.95 in each of these, I'm going to have 0.025 in each tail. Okay, because together that's 0.05 and that's complementary to 0.95. And since my sample size is 8, my degrees of freedom will be equal to 7. Okay. So remember, just to calculate the degrees of freedom in this section, it's your sample size minus 1. Okay, so that's how I got a degrees of freedom equal to 7. So to get the critical value in the table, the t-distribution table, I'll want to read down to my degrees of freedom, which in this case is 7. And we're going to read over so that we have a 0.95 level of confidence, okay? And you'll see that right below it, it says 0.025 in one tail, and we have 0.05 combined between the two tails. So that's consistent with my sketch. Okay, I have 0.025 in one individual tail. If I add the 0.025s together, I have 0.05 in two tails. Okay, and then my level of confidence is 0.95. Okay, so I'm going to read down to 7 degrees of freedom and over to the right column. okay, my 0.95 level of confidence. So my critical value in this case is 2.365. Okay, so my T sub C is 365. Okay, so now I can just go ahead and plug and chug, put in the pieces. It's going to be 35.5 plus or minus 2.365 times sigma, which is 7.2, over the square root of n, which is 8. Okay, so let's go ahead and find the margin of error part first. Okay, so I'm going to go ahead and put that in my calculator. Okay, I have 2.365 times 7.2 divided by the square root of 8. Okay. All right, so I get about 6.0203. So I can go ahead and add and subtract that from 35.5. So 35.5 minus that value is about 29.48. Okay, that's my lower limit. And my upper limit, I want to add that margin of error to 35.5, is about 41.52. Again, you'd want to round to however you're told to round in my math lab or my stat lab. Okay, so this is going to be a 95% confidence interval for mu. Okay, so to get this directly in the calculator, because it says if convenient, use technology. Well, it's always convenient. I want to go to stat. I want to right arrow over to tests. It's the same screen as where we found the z-interval. That's for the population mean when sigma is known. We're using the t-interval for estimating mu with an interval when sigma is unknown. Okay, so I'm going to select the t-interval. And I either have the summary statistics, which is what I have for this problem, or I'd have the raw data in a list, which I don't have for this problem. So I've got a bunch of old stuff in here. I can clear it out. Okay, so my sample mean was 35.5. And my sample standard deviation is 7.2. My sample size was 8. And I can change my level of confidence if I want to. But this problem asks for a 95% level of confidence. Then I'm going to press calculate. Okay, so you'll see that the calculator gives the interval just about the same, okay, rounding to the hundredths place as the one I got by hand. Okay, so using the calculator is fine. I will later show you how to use StatCrunch to get the same information. Okay, so we have 29.481 up to 41.519. Okay, so I hope that helps you get started. Usually the tricky part doing this by hand is finding the critical value, but you just want to make sure that you sketch what's given and put in the level of confidence, shaded as an area in between, and that way you'll know how much area is in the tails, so you'll be able to find the right column.